A smart Infuse pump based on Internet of Things for time efficiency and emergency situation monitoring. In the last 3 years, the world was experienced a COVID-19 pandemic. With patients who already have a history of chronic disease and then suffer from COVID-19, the treatment must be intensive. Patients like this are people who are most at risk of being fatal if exposed to coronavirus. Therefore, the treatment given is even more intensive than ordinary patients. One form of treatment provided is the use of life support tools such as ventilators or infusion pumps and intensive monitoring by nurses. However, this is difficult to do when considering the number of patients that can reach hundreds of people. Therefore, remote monitoring and control of life support tools in real time using Internet of Things is the solution. We would like to present our research, which is a smart Infuse pump that fabricated using nautical Internet of Things module. This modification will allow users to monitor several patient life support devices at once. Spontaneous troubleshooting of device's hardware failure so the device could be fixed quickly and be used again. Remote control of life support device, which is very helpful for an isolation area. Every Infuse pump have a flow sensor that connected to CPU then to an alarm. Connect the nautical to the line between CPU and alarm. When the pump is used, the sensor will send signal to the CPU. When it stops sending signal because the flow is stopped, the CPU will send signal to the alarm and thus the nautical also get the signal. With the proper programming, this will send a notification to the user's phone. Same as before, but now we connect the nautical to the input and feedback line of a certain hardware. The CPU will send command to the driver. Then the driver will send signal to the target device. The target device will run and send a feedback as a response. When the target hardware didn't send feedback, the nautical will alert the user something is wrong with that specific hardware. This time connect the nautical to the driver.
Hey man, what are you doing?
Okay, I'm making new wiring for work testing phase.
Oh,
Let me
that's
show you how
good.
it's work.
It's good.
Okay, so we have the device that want to be made into IoT, the IoT module, and this is the wiring that I made earlier. This is female port jumper cable plus with crocodile clip. Yeah. So the step is we connect the female jumper cable to the module, then we connect the clip to the place that want to be monitored or want to be manipulated. For example, I want to monitor the sensor, then this is the sensor port. I connect it there. So, and we can use the other jumper cable for other places. For example, this is the alarm port. If we want to monitor the alarm port, we can connect it here. This is the driver, motor driver. We connect it here, and so on.
With a signal from user's phone, the nautical will command the driver instead of the CPU to run the hardware. We intentionally clogged the pipe to test the result and the phone receive a clogged warning notification. This time it's the power supply that being tested by plug out. Same as before, but it's the motor that drives the peristaltic mechanism. When the flow sensor plugged out, the same thing also happened. This is the remote control panel that allow users to do long distance control. Patent potential and commercialization. Our product is in the process of registering a patent or a simple patent at the Directorate General of Intellectual Property, Sky, Indonesia. In addition, our product are also being refined for later mass production by companies under the auspices of our campus spin-off company, Menteri Maju. Potential user, target marketing, hospital and university.